All right, this is problem 132 from chapter 4 of the Halliday and Resnick book. So we've got this track meet where they're having a shot put contest. And it tells us that a shot putter releases a shot at a point 2 meters above the ground. And then here's our plot of the position of the shot put, or of the shot, I guess, every 0.5 seconds. So this is 0.5 seconds, this is 1 second, 1.5 seconds, 2 seconds, and 2.5 seconds later, it's back to a height of 2 meters, right? So at that point, our vertical displacement is 0. Okay? So we're trying to find the velocity in unit vector notation. Well, finding Vx is pretty easy because look, what this picture is showing me is that the shot put traveled horizontally a distance of 25 meters in 2.5 seconds. So my horizontal velocity is just going to be the displacement that I went through horizontally divided by the time, right? Because our horizontal velocity is constant. So we're going to go 25 meters, 2.5 seconds, 10 meters a second. There we go. So now all we got to do is we got to find our VOY, and then we're done, right? So this is a little bit trickier. You got to use a system of two equations. Since there are two unknowns, the two things we don't know are our VOY, and unfortunately, we don't know why my board won't cooperate. There we go. We don't know the acceleration of gravity on our planet. All right. So here's what I'm going to do. One of the equations that we know is this. We know that the vertical displacement of a projectile is equal to 1/2 of the vertical acceleration. So that's going to be our, our g, right? Times t squared plus VOY times t. Okay, there we go. So what I'm going to do is there are two things in this equation that I don't know. I don't know my vertical acceleration, my gravity, and I don't know my VOY. So what I'm going to do is I'm going to pick 2 points to get two different equations. Okay, so let's do 0.5 seconds first. All right, so during those 0.5 seconds, my vertical displacement, my vertical position is going from 2 up to 6, right? So my vertical displacement there is going to be 4 meters. Okay, so that's equal to 1/2 whatever my vertical acceleration is times my time, which is 0.5, and then you got to square it, plus VOY times 0.5. Okay, so that gives me this. 4 meters equals 0.5 squared is a quarter. Half of that is 0.125 plus 0.5 VOY, right? Okay, so that is one equation. All right, and then the other equation I'm going to get by using 1 second. So after 1 second, my vertical position is 8, which gives me a change of 6, right? So here's my new equation. My vertical position changes by 6 meters, so that's 1/2 AY times my time, which is just 1 squared, plus VOY times 1. Aha. Okay, so that gives me this equation. 6 equals 0.5 AY plus VOY. Okay, so what I'm going to do then is I'm going to take this equation and this equation and solve. So how you do that, I guess there's a few different ways. Initially when I did it in my notes, I actually just did that by doubling the top equation and then subtracting them, but maybe, yeah, I guess that's probably just as easy. All right, so what I'm going to do is I'm going to double this top equation up here to get this. I'm going to get 8 meters equals 0.25 AY plus VOY. And then my bottom equation remains the same. 6 meters equals 0.5 AY plus VOY. And now I can just subtract, right? So 8 minus 6 gives me 2 meters. 0.25 minus 0.5 gives me negative 0.25 AY. And then VOY minus VOY, those cancel out, right? So multiply both sides by 4, and you get, I was terrible about my units here. I just kept track of the units here. So anyway, this, if I kept track of my time, the units would work out here. Over here, I've got seconds squared. So anyway, multiply both sides by -4, and you get -8 meters per second squared equals our vertical acceleration. So there we go. That's the magnitude of acceleration on the planet. Okay. So that's part B, and now that I know my AY, I can find my VOY. So let me clear up the board a little bit. Almost done. We're through the nasty bit. Oh, come on, here we go. You gotta make sound effects or it doesn't work. There we go. Okay, cool. So now I can find my VOY, right? So let's do that in blue. So I'm just gonna use this guy. 6 equals 0.5 times negative 8 plus VOY. So 6 equals negative 4 plus VOY. Add 4 and you get VOY equals 10 meters a second. So there we go. We know our Vx is 10, our Vy is 10. So here we go. Here's our Vx, here's our Vy. Cool. All right, and then finally, how long after it's released does the shot reach the ground? So basically, I guess there's a couple ways you could do this. So I guess one way is this. Put a vertical displacement of -2 in there, and then solve for t. But doing that requires that you use the quadratic formula, which I have made no secrets about. I hate the quadratic formula. So I am going to do this instead. I happen to know that 2 times the vertical acceleration times the vertical displacement is equal to Vy squared minus Voy squared. So 2 times -8 times -2 meters, right? Because between here and the ground, it's got to go down 2 meters. So that's got to equal Vy squared minus our Voy. We found that before. That was 10, right? All right, and let's solve that. All right, so if you solve that, you get Vy equals 11.4891, blah, 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 blah. All right, again, hanging on to extra digits so we can round later. All right, so there's our Vy. Now, let's see. To solve that, I took a square root. And when you take the square root, that means you got to do positive or negative. And I am looking for, at the end of the time, it's gone down 2 meters. So it's moving down when it hits the ground over here somewhere, right? So we're going to make this guy negative style. All right, so then I'm going to find my time. Time equals Vy minus Voy over Ay. So my Vy was negative 11.4891. My Voy was 10. My acceleration is -8. Plug your numbers in, solveify it, and you get 2.7 seconds if you round down to your appropriate number of sig digs. There you go. All right, hope that was helpful.